We're now going to look at a set of problems that have as its keyword the phrase "at least." We're going to begin by looking at an example. Our problem says a game is played by drawing 4 cards from a deck and replacing each card after it is drawn. Find the probability of drawing at least one ace. And so you really want to key in on this phrasing as you read the problem. So what I have done on the left-hand side of the screen is written down some options that we have for drawing a 4-card hand that has at least one ace. So we want to be sure that in each case we actually have a total of 4 cards drawn, and that in each case we have at least one ace. So let's look at the first one. The first one says that we could draw 1 ace and 3 other cards. So 1 ace and 3 other cards does make a 4-card hand, and it does have at least one ace. Another option would be to draw a hand that has 2 aces and 2 other cards. This would be 4 cards with at least one ace. Another option would be to draw a hand that has 3 aces and 1 other card. Again, that would be a total of 4 cards with at least one ace. And the other option is to draw all 4 aces. Now, if we are working this problem directly, then what we're going to need to do is calculate each of these 4 options kind of like a separate problem and then add them together. And so obviously that's going to be quite a bit of work. So we want to ask ourselves if there is an easier way to approach this problem. So there is one option that could happen if you draw 4 cards from a deck that is not listed here in our list. And that option would be the possibility of drawing 0 aces, and 4 other cards. Now, this is certainly not answering the question as it's asked, because this is a hand that does not include at least one ace. When we do this, what we have found is what's called the complement. And sometimes as we're working problems, we will find that it might be easier to find the complement instead of finding all of this. So let's work on finding the complement for this problem. So I essentially want to find the probability that when I draw 4 cards, I get no aces. So let's look at this one card at a time. When I draw the first card from the deck, what is the probability that I do not get an ace? We know that there are 4 aces in the deck, which means that the other 48 cards are not aces. So we have a 48 out of 52 chance of not drawing an ace when we draw the first card. Now, go back to the problem and notice that we are replacing each card after it's drawn. So that card that we draw first goes back in the deck, and then we reach in and draw a second card. The probability that the second card is not an ace is the same, 48 out of 52. We replace that card and then draw the third card. The probability that it is not an ace, 48 out of 52. Replace the card and draw the fourth card with the same probability. So I'm going to go ahead and multiply this out and get an answer for this part of the problem. And I'm going to leave it in decimal form, so this is going to be 0.726. Now remember that this is the one option that we don't want. This is the one option that does not answer the question being asked. However, it's very useful to us to know the probability of the complement. And the reason why is because if we know the probability of the option that we don't want, then we can back into the probability of the options that we do want. In other words, if this is 0.726, then this, all of these options together, has got to be 0.274. And so this is based on the fact that when we look at all of these options together with the complement, we have looked at every possibility. And when we take the probability of every possibility and put them together, we should get 1. And so if we want to find the probability that is being asked in this question, then we essentially need to take 1, which is the total of the entire sample space, and subtract off the part that we don't want. And when we do that, that's going to give us the answer to the problem. 0.274 would be our answer. So let's go ahead and try it one more time. Our next example says that a coin is tossed 5 times. Find the probability of getting, and again, we are told, at least 1 tail. Now, I could go through the various options for what at least 1 tail means in terms of tossing a coin 5 times. However, I'm going to go ahead and shortcut this, and I want to jump ahead and write down the complement. Remember that your complement, and I'm going to flip back to the previous example, our complement had 0 of the thing that we were looking for. So at least 1 meant 1, 2, 3, or 4, but the complement was 0. And so you'll find as you're working these problems that when the problem says at least 1, the complement is always none. And so the complement is going to be the probability of getting no tails or 0 tails. Which, when you're talking about a coin being tossed and you're looking for the probability of not getting a tail, we're really talking about the probability of getting heads. Okay, so let's go ahead and calculate the probability of no tails. So I'm going to toss the coin the first time. What are my chances of not getting tails? We know that to be 1/2. I'm going to toss the coin the second time. The probability of not getting tails is 1/2. And we're going to do the same thing for each of the 5 tosses. When we multiply this together, we're going to have a 1 on the top, and 2 times 2 times 2 times 2 times 2 is going to be 32. So we now know that the option that we don't want, the one that doesn't answer the question, is 1 out of 32. So what is the answer to the part that we do want? Again, remember that when we take an event and its complement together, the probabilities equal 1. So in order to find the answer here, I can take 1 and I can subtract off the part that I don't want, which is going to leave me with the part that I do want. And so my final answer is going to be 31/32, or as a decimal, 0.97.